because I wanted to begin with introductions. And Arjun, you are our guest. And so why don't you quickly introduce yourself, tell us a little bit more about Connext, and then we'll move to the others.
Yeah, absolutely. I'm Arjun. I'm one of the founders and project lead of Connext. Um, let's see, I've been in the space since 2016. I became interested in the space because I wanted to find ways to build public goods that are both non-sovereign and non-corporate. I think it's really important for the world if you can have some types of things that exist, so sort of like the internet itself, that exist that are accessible by anybody and that are really untamperable by any specific entity. I think that's really how we get to a world that makes sense in light of things like globalization. I was always really interested in infrastructure, so I was working on like infrastructure startups in the space in 2016 and 2017, and then in May of 2017, I started Connext with my co-founders, Lane and Rahul, and the goal was always this technology, Ethereum specifically, is at the time is like extremely important and let's figure out ways to get it into people's hands faster. And so pretty quickly that led us down the path of scalability because that was really the biggest bottleneck for everybody. And we became scalability researchers in like early 2018. We built one of the first ever L2s on Ethereum. This was a state channel network in partnership with SpankChain because SpankChain was the only place that actually had any traction in the early days of the Ethereum community. And then we ended up continuing to do research alongside the kind of core scalability community. That's how I met John, for instance. And then as that community started to focus more and more on rollups, we became interested in interoperability, basically communicating between these different rollups and between potentially other sovereign chains, finding ways to make that experience seamless if we're moving execution into many parallelized environments. Which is actually a really good segue into this talk.
Awesome. And then from our side, we have John and Mustafa. Mustafa, please introduce yourself, and then John.
Hello, I'm the co-founder and CEO of Celestia Labs, which is the first modular blockchain network. And the basic idea is that we're building a modular consensus and data network to enable anyone to very easily deploy their own blockchain with very minimal overhead without them having to worry about deploying their own consensus network. And they can do that by deploying a rollup, or more specifically, a sovereign rollup on top of Celestia. So I've been thinking quite a lot about like bridging in a multi-chain world, and I've written some things about this topic and this idea of trust minimized bridging and also committee-based bridging. So I'm looking forward to have discussed these topics more in this space.
Sweet. John?
Hello, everyone. My name's John, also co-founder of Celestia Labs and the chief research officer. So I generally do protocol research and specification. Previously, I was at Consensus doing general layer 2 scalability research, where I met a lot of the fine folks that are on this call today.
Great. And we'll introduce James when he joins. In the meantime, I will set the stage for the conversation and let's get right into it. So if you are listening to this Twitter space, you know something about where the world is going. You can likely see that we are in the midst of a complete tectonic shift in blockchain infrastructure. Much of this innovation is driven by deep frustrations with monolithic chains. In a single word, that change can be summed up in the word modular. And many are saying that modular is now a movement where we're seeing early signs of a new culture, values, and even customs. Lately, what has caught my interest is the intersection of interoperability and modular blockchains. I found myself asking the question, what will the future of secure bridging and cross communication actually look and feel like in the modular world? Gents, I'm intensely curious about the changes that are going on right now at this exact moment in time in regards to that intersection that I just described. Specifically, I want to go deep on the trends and forces at play that are obvious and not so obvious. And I want to cover a wide range of topics For example, I want to go into clusters, optimistic bridging, token fragmentation, bridge failure. We'll talk a little bit about modular interoperability, systemic risks, the whole 9 yards. And what better way to just explore all this stuff through a true meeting of the minds with Arjun from Connext, James from Nomad, and then Mustafa and John. Arjun, on the 24th of January, you and Nomad announced a strategic partnership introducing the modular interoperability stack. Why don't we start off with you? Can you introduce the concept of modular interoperability and how it fits into the modular blockchain thesis?
Yeah, absolutely. So before I do that, let me just give like a really, really high level background on like what Connext is right now, and then what Nomad is right now, and then how those two things really like fit together. So Connext at the moment is a liquidity network, cross-chain liquidity network. Basically what this means is that we have a network of LPs called routers that hold pools of funds on different chains, and using a technique that is very similar to atomic swaps, allow users to swap, kind of like one-for-one assets across chains. From a user experience perspective, this doesn't look like a swap. It just looks like a transfer of funds. But the goal is that the user ends up with the right asset on the right chain, on the right destination chain for a fairly minimal amount of fees and almost no trust. And this is a model that has been like explored for a very, very long time. We have optimized the shit out of it, but it is something that like we've understood the trust considerations around for quite a while. Nomad, on the other hand, is a completely novel mechanism for interoperability, and it's specifically targeted around more generalized message passing. So, what we do with Connext, which is sort of more of like an atomic swap style thing, what we call like a locally verified mechanism for bridging. That mechanism is trust minimized and it's easy to deploy places, but it's not. We can't really use it for like arbitrary data passing, only some kinds of data passing. Whereas Nomad, on the other hand, is the other end of the spectrum where it is specifically designed to allow for passing any kind of message between chains. So allowing for one contract to read the state of another contract, for instance, which is a really, really important and difficult problem. Now, historically, the way that this has been done is by using something called, one of two ways, either through like light client header verification, like IBC, where you have one chain actually running a light client of another chain. And of course, this is difficult to do because it's custom to each chain, and each time you have a new consensus model or anything like that, you have to come up with an entirely new strategy for how to do it. Or through what is pretty much the most dominant paradigm right now in interop, which is using an external set of verifiers. So using like a POS network or an MPC network, or in like Layer Zero's case, like a two POS networks. But the idea is like, you have some external set of parties that is responsible for relaying the data across chains and verifying it. Now, what Nomad does kind of differently is that it says instead of just trusting some set of third parties to relay this data across chains, it uses an optimistic pattern similar to an optimistic rollup, where you relay the data across chains optimistically, and then you have a period of 30 minutes within which people can dispute. And if they dispute and find that fraud has actually occurred when relaying that data, then the entity that signed off on relaying the data, the updater in Nomad system, ends up getting slashed. So the security model is like more similar to that of something like a rollup than to something like a sidechain, which is true for most of the other kind of externally verified mechanisms. Now, the trade-off for Nomad, because there are always trade-offs, the trade-off for Nomad is latency, right? You have this 30-minute window within which you can't really do anything with that data because you can't really trust that it's accurate. On the other hand, you have Connext where these transactions are near instant, but they have limited functionality. They have limited. You have a limited ability to pass around data between chains. So our thesis around modular interoperability is that similar to the modular blockchain stack, where you can take different parts of the system, different like kind of pieces of what make blockchains important and what make them work, and separate them out into their own independent networks. So separate out data, separate out execution. And by having all of these things be built in a modular way, you can kind of offset the trade-offs of trying to build this like single monolithic blockchain that has this really complicated trade-off space around like the scalability trilemma that Vitalik has talked about. And similar to that, we think we can do the exact same thing with interoperability, where we use Nomad as the core message passing layer to pass data between chains, and then you use Connext as the liquidity layer. That gives you the ability to get the right kinds of assets on the receiving chain. You're able to, while Nomad messages would have historically taken 30 minutes, you're able to short circuit them in any user-facing case and make sure that they happen almost instantly through Connext. And but you still end up getting the core security guarantees of Nomad and really by extension of the underlying chains.
Thanks. I want to kick it over to the Celestia guys. Guys, react to me. Tell me about how you feel about this modular interoperability thing that Arjun is talking about. Any trends and forces at play that we'll have to take into consideration, or things that we cannot ignore? But just give me your general points of view.
Yeah, so I think one thing that might be helpful to the listeners here is to kind of explain this difference between what Connext and Nomad are trying to achieve, in the sense that there's this idea of a lock and mint protocol and a swap protocol. And correct me if I'm wrong, Arjun. But so with Connext, you have instant transfers, right? Because it's just, you can swap tokens. So with Connext, you can basically swap tokens, that already exist on two chains. So if you have two chains, like chain A and B, and some tokens exist on there, you can basically swap those tokens instantly.
Yes.
But then the question is what if tokens don't? What if you want to mint new tokens into that chain? So let's say you have a bunch of tokens on chain A, and you want to move them to chain B. But there isn't any existing tokens of your type on chain B, so you have to kind of transfer. You can't just swap something on chain B to move those tokens to chain B. You have to actually move them to chain B, mint new of those tokens on chain B, and that's referred to as lock and mint protocol, because you have to lock those tokens on chain A, and then mint them on chain B, and you're basically moving them to chain B rather than swapping them for existing tokens. And as far as I can understand, that's where Nomad fits in, and that's where you have this 30-minute latency, because you would only use Nomad if there's not enough liquidity on both chains, so that you can just swap those tokens instantly.
Exactly. Yeah, and I'm actually really. Oh, sorry. Go ahead.
No, sorry. Go ahead.
No. Definitely finish your thought.
Yeah. So I was saying that actually fits in really well with the kind of a roll-up centric or modular blockchain stack. Because with roll-ups, the way I see that roll-up bridging working in the future, at the moment, there's quite a lot of people critical of optimistic roll-ups, for example. Because they have this 1 week withdrawal period. For example, if you withdraw the tokens to Ethereum, if you want to withdraw tokens to Ethereum from a rollup, you have to wait a 1 week fraud-proof period. But with this, but you don't actually have to do that if you just swap the tokens. And a naive way of doing that would just be deposit the tokens to an exchange, swap them for the tokens, and then withdraw them to the chain that you want, using the exchange's withdrawal feature. And Connext is kind of doing that, but in a decentralized and more trust minimized way, by having a kind of this a cryptographic swapping protocol, which basically does the same thing as if let's say you want to move Ethereum to Polygon. Instead of using the official Polygon bridge, you can deposit Ethereum into Coinbase, or maybe not Coinbase. I don't know if Coinbase supports Polygon, but let's suppose it did. You just deposit the ETH to Coinbase, and then you withdraw it from Coinbase to the Polygon chain. So that's basically what Connext does, but in a decentralized way. And so I see, with rollups and with multi-chain bridging in the future, the way that I see it working is that you have one official or enshrined lock and mint bridge, where you move the tokens across those assets, that is completely trust minimized. That has high latency period, might be expensive to use, but you only have to, but only liquidity providers would use that bridge. The actual users themselves don't actually swap tokens to the official bridge, but just use atomic swap between chain A and chain B, rather than going through the official bridge, which is only should be used by like liquidity providers and whales effectively.
Exactly, yeah. And I'm really glad that you brought up this example of tokens and like token transfers and token minting, because that is actually the simplest, most quintessential example of the sort of the kind of domain space that Connext and Nomad occupy, where like you have with Connext, you have like the fundamental assumption, again in the token transfer case specifically, the fundamental assumption is that like that some liquidity exists on the receiving chain. You have to have some minted representation. So if you're transferring, if you want to, if you're on Polygon and you want to get to XYZ chain, and XYZ chain doesn't have a USDC representation, there's really no way to use Connext to swap USDC into that chain. We need somebody to mint those assets first. And that is really where Nomad comes in, is that like Nomad has the capacity to, with minimal trust, mint representative assets on a chain where they don't exist yet. And so from the, from our perspective, for instance, with Moonbeam, like this was a core part of how we've like collaborated, is that like, exactly as you said, liquidity providers, market makers, other institutional people who are trying to mint, $10, $20 million of liquidity at a time will do that through Nomad. They'll migrate that liquidity from Ethereum or from some other chain to Moonbeam, and then they will now, now that liquidity is available, some of it can end up in Connext, and that can be swapped over for users. And so the users still get this like less than 2-minute turnaround time, very cheap swap that can go from any other chain. But you still have this like safe mechanism to mint tokens. Now it definitely gets a bit more complicated than that. I think we'll certainly touch on like inter and intra cluster communication in the future, in like at some point on in this space. And I think there's like a lot of really interesting things that we can do there around, like Nomad may be quite possibly the best inter cluster communication option that there is. But at the same time, there are certainly instances where you may want to use like something more native for the intra-cluster piece. So like, use a rollup AMB in order to achieve the best possible security guarantees. And then the other dimension along which it gets more complicated is if you're doing something that's more complex than simply transferring tokens. And that is entirely possible with Nomad. And in certain cases, it's also possible with Connext. And so, those pieces we can kind of dig into in the future as well.
James, welcome. Do we have your audio?
I made it.
You made it. Okay, cool. Real quickly, introduce yourself, James, and then give us 1 or 2 lines on Nomad.
Sure. I'm James Prestwich, one of the co-founders of Nomad. I've been working on cross-chain communication and bridges for probably 4.5 years now. I started off in cross-chain atomic transactions with Bitcoin back in 2017. So Nomad is a new cross-chain protocol that leverages, kind of some of the techniques from optimistic systems in cross-domain communication. So you get cheaper, you get better throughput at the expense of some latency.
Awesome. We had opened up with the concept of modular interoperability. I mentioned the announcement on January 24th, where Connext and Nomad formed this deep partnership. And I asked, how does the concept of modular interoperability fit into the broader modular blockchain thesis? And so that's where we're dialoguing on now. John, we'll kick it over to you, your point of view.
I think it's a particularly important subject because as we've seen from the rise of various new blockchains in the past couple of years, things like Solana, for example, there is a need and a demand for systems beyond just a single chain with a single virtual machine with a single set of constraints and limitations. There's a demand for exploring the trade-off space, not just in terms of security and decentralization, like maximalists would have you believe, but the trade-off space in terms of things like complexity, in terms of novelty, and so on. There's a large trade-off space that doesn't necessarily involve harming the user's security or harming this notion of decentralization or sovereignty, while still being different than a single monolithic chain. And we are moving towards a world that is increasingly multi-chain, that involve multiple blockchains. Ideally, we want these blockchains to share security. For example, if they use a common consensus and data availability layer, such as Celestia, or some other mechanism. And these chains need some mechanism of communicating with each other. And this is where cross-chain communication protocols, such as what Connext and Nomad are building, are going to be very important in this future.
James,
one of the things I love about this is that what people don't realize is that multi-chain systems have always been and will always be the only scaling roadmap. Ethereum called them shards. We have Cosmos zones. We have Polkadot parachains. But it's all different flavors of multi-chain system. When we talk about cross-chain and cross-domain communication, this isn't something new. This has been an inevitable consequence of the Ethereum roadmap from the beginning.
Yeah, I mean, there's definitely like in the Solana ecosystem, like Anatoli's view is basically like we should have a single synchronous like world computer blockchain that processes transactions synchronously. But I think like anyone who's kind of built a large scale system before will know that's very difficult to do. Like if you look at the internet itself, that's not a synchronous. Like the web itself is not a synchronous system. It's a bunch of web servers communicating with each other asynchronously. And I think we will end up with a similar kind of architecture for Web3 as well. A set of blockchains communicating with each other asynchronously.
And
does anyone disagree?
Sorry, go ahead.
I was going to ask, does anyone disagree with what Mustafa said, or does anyone see it differently?
We agree to the extent that, and I think James and I have talked about this, that like effectively what Connext plus Nomad is really offering is asynchrony, not really as a service, but really just asynchrony to this world, right? Like async comms to this world that it just fundamentally doesn't exist yet. It's going to be completely new paradigm. People are going to have to completely change the way that they think about things in the same way that we have to completely change development paradigms to be able to build web applications. We'll have to do the same thing in blockchain development, which is certainly going to be a giant pain in the ass.
James, I think you were saying something.
Yeah, well, I was mostly agreeing and adding colors. The web is, not a synchronous system, and it's certainly not a homogeneous system. The internet is composed of, thousands and thousands of independent networks with slightly different software and slightly different semantics and network address translators, and all of these messy, systems, just to resolve the fact that the web is not synchronous. It's not homogeneous. You need cross-domain communication in the internet. And that happens, 10 times every time you make a web request without you thinking about it.
Question for the group. Celestia and rollups are examples of a modular blockchain protocols, while Nomad and Connext are examples of modular cross-chain communication protocols. Why do you think that modularity as a design principle has emerged in both of these contexts? And do you see this emerging in other areas of the blockchain stack?
Can any of us start? Go ahead, Mustafa.
Well, I think there's several elements there. I think Arjun also kind of elaborated on that well by talking about the trade-offs. From a cross-chain perspective, like every cross-chain protocol, every cross-chain mechanism has trade-offs. So I mean, obviously, like in the Connext case, like the atomic swap protocol doesn't work if there's no liquidity, and that's why you need Nomad. If there's liquidity, but the trade-off there is that Nomad has higher latency. So in that kind of world, it's a way to kind of like beat the trade-offs by having like kind of the best of both worlds in a way, in the sense that because the protocol is modular in the sense that it supports multiple cross-chain mechanisms depending on the use case or what's needed at the time. you can kind of like the user kind of effectively has more like flexibility over the use cases that it needs. And I think from a Celestia perspective, that's also similar in the sense that Celestia decouples consensus from execution, and it allows developers to define their own execution environments. And different execution environments have different trade-offs. And so the beauty about it is that because Celestia doesn't enshrine or enforce a specific execution environment for you, the developer has the freedom to choose whatever execution environment they want based on their use case and what trade-offs they need. Like whether they want to use the EVM, for example, or use the Cosmos SDK or some other, or Fuel or some other execution environment.
I think to that point, modularity is kind of a inevitable response to these unavoidable trade-offs we see in consensus systems, in cross-chain communication systems. The response is, rather than choosing one point in the trade-off space and planting a flag there and telling everyone they should come join it, we try to design these systems so that users can move throughout the trade-off space based on their use case.
I think also just to echo James's point from earlier, this is something, it's like modularity is a term that we have started to use in the last year and a half around describing these different systems. But like fundamentally, what this is just like layered architecture for distributed systems, right? That's something that we've sort of understood for a very long time, that like when building networks, this is true on the internet as well, by the way. When building networks, it makes sense to have each protocol or each like level of the stack be hyper specialized into doing one specific kind of activity, rather than trying to build a network that tries to do everything. And the reason for this is that like it's extremely difficult to constrain risk if you have a lot of, like, for instance, if TCP/IP was also handling network address translation, if it was also handling some of the higher level functionalities of things like HTTP requests, you would end up with just a much larger surface area that you have to think about in order to do things with the protocol. And in fact, you would also end up with a lot of this like extra stuff that you're not doing anything with most of the time. And I think that's sort of what exists with the whole modular blockchain thesis and the whole modular interoperability thesis, is that like fundamentally what we're doing is we're separating everything out into layers. We're saying the settlement layer is responsible for economic security. We're saying the data availability layer is responsible for storing data. We're saying the execution layer is responsible for executing in a virtual environment, and then like translating that into proofs that can be stored in a data availability layer. And by separating out the responsibilities of each of these different pieces of the puzzle, we are not only constraining the risk that anything goes wrong, but we are also limiting the need for each of these pieces to always be used. And this is really where the scalability piece comes in. I know this is something that John has talked about a bunch, which is that you don't actually need to have a general purpose VM, the full stack general purpose VM and chain running every single type of thing. You should, and in the future we will hyper optimize VMs to be specific to certain kinds of activities. And as long as the data layer itself and the settlement layer itself are the same, you can do that freely with minimal risk and still have the same level of security. And that is how you eke out the best performance, right? Is allowing people at higher levels to optimize without affecting any of the core properties of the system and without having to rebuild an entire system.
John, I want to give you an opportunity to weigh in.
Could you repeat the question to refresh the listeners' memories?
Yeah, Celestia and rollups are examples of modular blockchain protocols, while Nomad and Connext are examples of modular cross-chain communication protocols. Why do you think that modularity as a design principle has emerged in both of these contexts? Do you see this emerging in other areas of the blockchain stack?
Yeah, so I would say that before the separation of the actual blockchain process kind of became popular into what we currently see today as being the modular blockchain stack, you have your consensus layer, data availability layer, your execution layer, and your settlement layer, potentially wrapping some or all of them together into different layers, there were a number of projects that did modularity at the implementation level. So an example of this was the Cosmos SDK. And the Cosmos, just the entire Tendermint and Cosmos development ecosystem, where essentially they, black boxed the consensus process, and they made specifying the execution semantics modular. Right? They allowed you to just define your own execution semantics, bring your own VM essentially, and consensus would be provided. There's also other projects that are also doing something similar. Avalanche and Subnets, for instance, is essentially copying the Cosmos model, where they have, a consensus stack, the Avalanche consensus stack, and then they're providing some, for now, relatively primitive, but I guess they're in development, mechanisms for actually developing your own virtual machine. And they have a few currently application-specific VMs that are being played around with. I think they're launching some new Ethereum EVM-based VMs with some tweaks and so on. But that's an example where the implementation, rather than the fundamental design, was built around a kind of modular design principles. And with the rise of the modular blockchain stack, we've kind of extended this notion not just to the implementation, but fundamentally to the design. And this kind of takes the benefits of the modular implementation and makes them even better, and it takes them even more to an extreme. And what are those benefits? Why would the Cosmos SDK be designed like this? It's because when you make something modular, it means that whoever uses that system or whoever builds the system doesn't have to know and care about everything. They can only care about a subset of the features, and therefore it allows specialization. And as we know, specialization is one way to really eke out maximum performance, or maximum anything, really. It's just an amazing way to min-max, because if someone has to keep in their head how an entire blockchain stack works, that's just fundamentally not scalable, right? I don't think there's anyone in the world today that knows how the entirety of a Go Ethereum node works. Just not humanly possible. It's just too complex. But it is possible to know, for instance, how the EVM works, and not care about the peer-to-peer networking, not care about the consensus protocol, any of those edge cases or anything like that. Many people know entirely how the EVM works. So this allowing specialization allows us to get maximum performance. And this is why I think we've seen the rise of modularity, not just at the design layer, but also even at the implementation layer.
I want to move towards clusters. What are the biggest security differences between inter-cluster bridging versus intra-cluster bridging? And how do we see that changing in the next 12 months, 24 months? Mustafa, why don't we go with you?
Yeah, so this idea of clusters was set out in a blog post I released in October, where I was trying to kind of make sense and categorize the communications in the multi-chain ecosystem landscape. And the basic idea is, like, there isn't really such thing as layer 1 or layer 2 or layer 3. All there really is blockchains that bridge to each other. Like, conceptually, what is, like, layer 1 and layer 2 aren't really useful terms nowadays. It's more useful to think about what are the trust assumptions between different blockchains. Because layer 2 is basically a blockchain. Layer 1 is basically a blockchain. But why it's called layer 2 and what differentiates it is how they bridge with each other and the trust assumptions used by that bridge. So I came up with this idea of like inter-cluster and intra-cluster communication. So I defined communication between two chains as into two categories. The first category is this idea of a committee-based security. And that's kind of like the more traditional bridging mechanisms you would use. For example, like the bridge between Ethereum and Solana that uses wormhole, for example, that requires a committee and requires you to trust a committee to not steal your funds. Because effectively it's a committee, the wormhole bridge committee that signs messages to and that from with that bridge to and from Solana and Ethereum. And that committee could lie about to Ethereum, for example, about how many funds there are on Solana or what your balances are on Solana and vice versa. So like it could theoretically steal all the ETH in that bridge. Same with Polygon, right? The Ethereum to Polygon bridge. That's also a committee-based bridge. If I remember correctly, there's like a multi-sig of like a few people. Then if they're compromised, all the ETH on Polygon could potentially be compromised. And that's why Polygon it's kind of not usually referred to as layer 2 to Ethereum. It's kind of referred to like Polygon is just another layer 1. Even though Polygon, for example, the value proposition of Polygon is that it helps to scale Ethereum. All Polygon really is just another blockchain. It's a fork of Ethereum with Tendermint on top of it, consensus, with a kind of like committee-based bridge. So that's committee-based security, and then you have this idea of trust minimized bridging, and that's where rollups come into play. So with rollup chains, if you deploy a rollup chain on Ethereum, for example, and you like have a bridge between that rollup chain and Ethereum, then that's what I would describe as the trust minimized bridge. Because even if the operator and the nodes that operate that rollup misbehave and go completely rogue, then in theory they can't steal your funds. And the reason for that is because the Ethereum chain runs a light client as a smart contract for the rollup. And if your rollup chain has a malicious block producer that produces invalid blocks, then that can be proven using either a fraud proof or a ZK proof to prove that the block was valid. And so this is what I call chains that communicate with each other using trust minimized assumption. I call that as an intra-cluster communication mechanism, and I call chains that communicate with each other using a committee-based assumption as an inter-cluster communication. And this is kind of named after like the internet and intranet. So like with the internet, with the intranet is basically communication across your local network. So like if you have an office, and like all the computers in the office are connected to the same like local network, to the same router, they can communicate with each other using the intranet. But to communicate to other computers that are not in the same office, for example, or that are not in the same local network, you would use the internet. And so I kind of apply that concept to like the multi-chain ecosystem, and you have like intra-cluster and inter-cluster communication.
Good overview. Would anyone else like to add on this topic of clusters, inter versus intra, and the changes that you expect to see?
Yeah, definitely. Back in like 2017, 2018, when people were first investigating and talking about these kinds of things, we came up with a terminology, a hierarchy, which was essentially you have what Mustafa would call committee-based, which is usually a multi-sig. And you have the intra-cluster, the shared security, which we referred to as usually dependent or merged consensus, where the secondary chain is dependent on the primary chain. So an example of this is rollups, where the rollups consensus security is dependent on the L1. And the L1 is running a fully verifying rollup client under some assumptions. And in the middle is where we would put things like IBC, which is based on a relayed light verification. IBC relays don't do full state verification of the remote chain. They only do header chain verification. So I think in Mustafa's terminology, the relay and the dependent consensus would both fall as intra-cluster, while the multi-sig or committee-based would be inter-cluster.
So I would still define so with committee-based, I would still define like clients that only verify the headers, like clients that verify the signatures in the headers to check that the block headers have consensus. I think that's still theoretically committee-based, because the only difference is that the committee is simply the chain itself. But the reason why I make that distinction is because, like, if you create a new Cosmos zone with one validator, it's like it's potentially even less secure than like a third-party committee.
That's true.
So,
go ahead.
By the way, the impetus for this is just to kind of like give a little bit more context for everybody who's listening to this. The impetus. So this is the same thing that was kind of talked about in Vitalik's like cross-chain, not multi-chain post, where he was saying like fundamentally there are limits to the security that you can achieve when you have like two chains that have independent validator sets that are communicating with each other. And even if you built the most theoretically secure communication mechanism between each other, like like IBC, for instance, the bridge security might be foolproof, but the fact that you have two independent chains means that you now are still adding another risk layer, and that risk layer is that the one of the chains could get 51% attacked. You could force a fake update on that chain that then gets translated to fake funds being sent over the bridge onto the other chain. And so this is a way to kind of like spoof malicious data and send it over a bridge and into like a higher security environment like Ethereum. And fundamentally, that is true. There is this fundamental limitation that exists when you have multiple different chains that have their own independent validator sets. This exists within Cosmos and IBC. When you create new Cosmos zones, this exists. This wouldn't exist in the case of something like Ethereum and rollups, or I guess in any sort of situation where you have shared security, because in those cases you would have to the risk that you're taking on is really the risk of the single validator set being attacked. Now, I think that there is a fundamental limitation there, but I don't necessarily agree with the like Vitalik kind of conclusion, which is, okay, we should just not have multiple validator sets. We should have just one. We should just not have inter-cluster communication, because the reality is people are just going to do it like this. They're going to find ways to do it, and even if those ways are completely trusted, because people are idiots, and also because like the market wants it, and like I think James, you kind of I think you had a tweet about this where you were just like, it's man in the mountain energy. Clearly, people are going to do it. USDC exists, WBTC exists. Like, we're not going to avoid these things. Let's find ways to actually lean into it.
Fundamentally, you have to look at the market and say, people are using USDC, they're using WBTC. These are functionally committee-based cross-domain systems. And there's such incredible market demand for these committee-based cross-domain systems that you have to admit that people will always use them, and there will always be huge amounts of value locked up in them. You can't have this mountain man single validator set for everything. The market has rejected that.
I have a spicy analogy for this, which is that sex is risky. It can give you STDs. It can lead to pregnancy. But the solution is not to tell people don't have sex and be abstinent, because they're never going to listen to you. They're still going to have sex. The solution is to make contraceptives extremely easy to get. So we just need bridge condoms.
Yeah. But I think the idea why I think like the logic of Vitalik saying we should not have a multi-chain ecosystem, just a cross-chain ecosystem. I think the kind of Ethereum roadmap expectation is that like Ethereum will scale kind of like infinitely to some extent using this roll-up centric roadmap. Like it will have very like high data availability capacity, and like so you can support lots of roll-ups onto that. But I think that's still basically an important part Like even if theoretically speaking, you had a chain like Ethereum that could support an infinite number of rollups, an infinite number of data, so you don't need to spin up a new chain. I still think that's kind of missing an important part of why we need a multi-chain ecosystem. And that's because there's several reasons for that. Like the most important underrated reason is like these different like clusters of chains have different values, not just both from a technical perspective, but from a also a social perspective. Like maybe you don't want to have it. Maybe you don't want to be like limited to the EVM as a settlement layer. Like maybe you want to have a parallelizable virtual machine like Solana, for example. But also you might have different social values. Like look at Ethereum and Ethereum Classic. Different values there. So I think either way, like we will have a multi-chain ecosystem.
So Mustafa, I definitely agree with you. By the way, I want to couch this in saying I agree with you, but I want to also play devil's advocate because this is definitely an important question, and I think it gets asked a lot. And the question is, if the thesis of having the economic security associated with a settlement layer being as high as possible to resist sovereign corruption, to resist corporate corruption, if the thesis is you want to make that as high as make that as secure as you can, why not just have a single settlement layer? Why not have, you could potentially have diversity at the execution layers and the data availability there, but like from a objective world outcome point of view, isn't it much better for security to say, let's just stack all of the security in one network of validators?
So that's theoretically possible if, as long as you are happy with the idea that the resource requirements to produce a block or to participate in the production of blocks in that settlement layer could potentially be very high. So like as a thought experiment, like let's say you want to take Solana to extreme, because Solana's value, for example, is like to produce blocks in Solana, you just need very high resource requirements, and we're just going to scale that. We're just going to make a web scale blockchain where you have like unlimited resource requirements to produce blocks. Like how far would you take that? Like let's say in theory you could take that to something that eventually looks like a MySQL database, like a Web2 MySQL database, and you have like something like Google scale, and you somehow figure out how to like Merkleize that database into like a single Merkle root. So it's basically a blockchain. The question there is, would the community be happy with the fact that the kind of requirements to produce blocks would be so high that you basically need to be like a corporation to produce those blocks? Like the answer might be yes to some extent, because if you've looked at Vitalik's recent like endgame post, his entire thesis there is that you will have centralized block production, but decentralized verification using things like data availability sampling and fraud proofs and ZK proofs. But then the question is like, still, how far do you want to take that to an extreme? Like, do you really want to take that to an extreme where only like Google level companies can produce blocks? And if the answer is no, then you do need multiple settlement layers and a multi-chain ecosystem.
I think at this point we've basically all agreed that there will be a multi-chain ecosystem with multiple settlement layers. And I want to bring it back to talking about modularity in bridges, because that's fundamentally a very difficult thing to reconcile in cross-chain communication. How do you deal with so many different chains, so many different execution environments, and so many different choices for cross-domain communication? If we want to use this intra-cluster communication as much as possible, but we're forced to occasionally use inter-cluster communication, how do we resolve that for any application? The way we've been approaching this at Nomad is to completely abstract the communication mechanism from the application, and to have any application be able to enroll any number of communication mechanisms. So the same logical token bridge application can use IBC or Nomad channels or whatever other inter-domain communication mechanism is available. We're still in really early stages of rolling this out, and it's very complex in practice. I was wondering if anyone else had strong opinions on what standards in that should look like.
I mean, like everyone's, I think like I know there's IBC, for example, and then there's also like Polkadot standard. But like, would you consider like IBC as a standard? Like, for example, as the like at least packet protocol, packet format protocol,
Well,
for example.
I like, packet format protocols. I like as a developer just getting some message in off the wire and deserializing it locally. And, I guess my question is like, we have to separate the packet protocol layer from the application layer. How does your token bridge handle these packets, and how many different channels can it get packets? So we need standards for, enrolling channel, connecting the channel to the application and passing packets from the channel to the application and handling the packet. And I'm still not sure what those look like in the long run. Like this, we're talking about modularity a lot. This is, what do you do at the layer boundary, and what is the correct format for that interface?
So is the problem there, if I understand it correctly, like one where, like if you have different execution environments on your chains, you have to have different like libraries to like process those packets effectively, and like to, for example, like deposit and withdraw assets in those written like compatible with those execution environments. Like with the EVM, for example, you have with the EVM you can have a Solidity contract, or with like Solana you have a Solana contract. Am I understanding that correctly? The question.
So suppose that you have a consider like a EVM, Ethereum, Evmos, and Osmosis, for example. This is something that we think about today. You can connect Ethereum to Evmos with Solidity on both ends. You can connect Evmos to Osmosis with IBC. Hypothetically, you can connect Osmosis directly to Ethereum with some other channel. How do you reconcile the unified application, that you want moving tokens between those three chains, and the different communication layers underneath them? Each of those three connections might have different semantics or different layout, and we need to connect them to essentially the same application on top, which might be expressed as a Cosmos module or a Solidity contract. So there's kind of this, just interfacing between the application layer and the communication layer is very difficult and kind of not yet standardized.
Yeah, I guess the main difficulty there is that like all these chains have different like execution layers, and so like like for example, Osmosis does not support like generalizable smart contracts. So like hypothetically speaking, like if Osmosis, like if Ethereum Evmos and Osmosis all supported like general EVM contracts, then you can probably have the same kind of communication between all those chains if you just like deploy the same smart contracts in Solidity. So I think that it sounds to me like the bottleneck there is like the fact that in Osmosis you've got a hard coded you have to use IBC, for example, if you want to use official bridge. But there's no generalizable like smart like environment where you can like add like deploy code into it.
Yeah, Cosmwasm soon, I hope. But we have to like for each communication channel, you have to build it in the local, the local language in the Cosmwasm or in the EVM. And then for each application, you have to connect it to those channels in a predictable, understandable way. And you have to build the application so that it is, abstract over many different potential channel types. This is a huge challenge, and we are, kind of slow rolling our approach to it. today we have this very abstract handler pattern where, some channel calls into the handler with a bunch of raw bytes that have already been authenticated. But we don't know whether that'll continue to work for IBC or for Polkadot's XCMP or for other communication patterns in the future. So we're still in very early stages of building out the modular bridge stack and getting the interfaces between all the different modules correct and usable.
Yeah, there's also a lot of other pieces, other open questions that exist around this too. So we have the liquidity and messaging layers that are live and in production and kind of now being figured out how those will interface with each other. But there's also a lot of open pieces around okay, I think you need some sort of gateway protocol that allows you to connect between Nomad to other localized communication mechanisms like IBC. And I think you probably need some sort of NAT protocol that allows you to translate addresses between these different systems. Nomad has a concept of chain agnostic domains, but we will need to translate those into localized addresses everywhere in order to actually execute anything to any destination contract. So these are the kinds of interesting challenges that remain, where there's similar to the internet itself. There's just there's a whole host of protocols like BGP and things like that will need. It really will kind of need corollaries in this space. We will need to have that kind of functionality exist, and we'll need to make sure that functionality is simple, it's very well specified, and it's available for everybody. These are open protocols that people can then start building against, so that we do end up in a world where there is a single path for users to get from contract on chain A to contract on chain B, even if those two contracts, even if those chains are in totally different clusters, and if you're having to go through a few different hops of messaging protocols in between to get there.
I'd like to transition a bit here. You guys are already somewhat discussing this. The question is, part of the value proposition for modular blockchains is that we can have many different execution environments running side by side. However, having a multitude of execution environments poses difficulties in bridging between those chains. How do we resolve this conflict? Is this where modular bridging protocols come into play?
We're running this right now, and I touched on this a little bit. For any good cross-chain communication system, you have to implement it in the language both ends of the communication channel. So if you want to connect EVM to Solana, you have to write it in Solidity and in Solana's Rust. And you have to write, the same application on both ends so that they can communicate together. Right now, we have planned ahead for that, but we haven't yet done a second implementation of the Nomad protocol. What we've planned ahead for is, allowing extra space for addresses, because, not all chains use 20-byte addresses like Ethereum. Most of them use 32. Putting as many things as possible in very agnostic, very general patterns. So for example, we don't use ABI encoding because that's a Solidity pattern, not a Solana or a Near or a Cosmos pattern. And making the interfaces, as simple as possible. We kind of expect that as we spread out to more chains, we're going to run into more and more things that we neglected to consider in the initial design. So really excited about all of the fun bug fixing and resolution we have to do for the protocol in the future.
So I think one thing that might or might not help with this in the future. Optimism recently released this interactive fault proofing system called Canon, and what they've done there is they've implemented a MIPS machine in the EVM, and then they've compiled Go code into MIPS, and so this MIPS machine kind of acts as a virtual machine on the Ethereum virtual machine, and you can compile arbitrary Go code and other code, potentially WASM code, or WASM code, into MIPS. So in theory, you could potentially run any kind of execution environment on top of the EVM as a virtual machine. Like in the same way, like you could run like a Docker container with a different operating system on your like own computer to run other applications that might not be supported on your machine, instead of having to necessarily like rewrite the application in every single like language or like execution environment that needs to be supported. So that could potentially help in the future with like preventing the need to write multiple code for bridging in multiple different execution environments.
Yeah. Optimism's MIPS machine, kind of based on Arbitrum's earlier WASM machine doing the same thing. These really open up a lot of possibilities for more direct, optimistic, full verification of remote chains in the EVM. I'm excited to see these productionized over the next probably like 2 to 5 years. It's going to take a while, but they're going to do really cool things in the long run.
I want to begin taking Q&A from the audience pretty soon here. So if you have a question, raise your hand. Before we take that first question, Arjun, I wanted to ask you something specific. Can you explain for the audience what is optimistic bridging and what makes it different from most other bridges that operate today? And why is Connext so bullish on this?
Yeah. So, I mean, I'm sure James is probably going to give a better explanation than I can, but I'll try to give like the best explanation that I can, and then James, let me know if there's anything that I missed or that is important that I've missed. So last year we wrote about something called the interoperability trilemma, which is that there's at least with where the market was at the time, every single interoperability project that existed kind of fell into one of three categories, and that was it basically came down to who is verifying the system, who is actually responsible for deciding what data gets relayed between chains and how that data gets relayed. And there were three real options there. The first was native verification, which is the chain's own validator set, or the receiving chain's own validator set, is responsible for validating the data that actually gets posted to it. And this is things like well, there's two options here. There's things like XCMP, where you have the core validator set of Polkadot is responsible for validating the data that goes across chains. Or you have things like Cosmos and IBC, where the receiving chain validator set is like running a light client of the sending chain, and then validating like the block header of something that gets passed through it. Then you have externally verified systems, which as I talked about before, are like multi-sig, MPC systems. Layer 0 is another example of this, where really you just have like a third-party set of validators doing this. That has their completely own set of security trade-offs that is different from either of the two chains. This one adds a lot of trust assumptions. In some cases, it could be okay. So like one case where it could potentially be okay is if like the security of that third-party validator set is much better than the security of either of the chains. In that case, it's totally fine. But of course, it can be hard to really figure that out. And for at least any of the larger clusters like Ethereum, you're realistically not going to end up in a situation where your interoperability protocol has better economic security than Ethereum does. It's just very, very highly unlikely at this stage. And then the last one is kind of what Connext does currently, which is local verification. So you, instead of having this like big end party problem where you have some set of people that are responsible for passing arbitrary data between chains, you do something like an atomic swap. You isolate to two people, the two parties, and then you have them just communicate with each other. And taking a two-party communication mechanism and making that trustless is something that we do actually understand quite well. And it is quite easy to make that as at least very, very reasonably trust minimized, more than most other options out there. Now, the assumption at the time when we wrote that post was that there was this trade-off space that exists between these things. And you could really only have like 2 out of the 3 core properties of like trust minimization, generalizability, which means being able to pass around arbitrary data, and what we called extensibility, which means the ability to take this core product and like copy pasta it across many different chains, which unfortunately with like light client header relays, things like that, it's not very easy to do because you have to build custom implementations. The reason that we're really, really bullish about optimistic verification is it's the first like approach to interoperability that is genuinely novel beyond the three prongs of the trilemma that we have explored in the past. And we think it's interesting because fundamentally it changes the trade-off space, so that rather than having to choose between being trust minimized, being generalizable, or being extensible, you are able to actually get all three of those things fairly easily. And instead you choose this other trade-off, which is latency. Now, latency is bad from a user perspective, but from like an institutional perspective, or from a security perspective, or even from like just an implementation design perspective, it's really not a huge problem. And latency is something that we can fix. Latency, the march of technology is very, very good at making things faster. We're very, very good at optimizing on speed and on cost. We're very bad at optimizing on some of these other core properties like security, just through engineering work. And that's the reason that we're extremely bullish on the optimistic verification model, is that in combination with the way that Connext works currently, we can get pretty darn close to what looks like a perfect model. Of course, there are still instances where you'll have the 30-minute nomad latency, but aside from that, aside from the rare instances where that happens, and most of those are like DAO-facing use cases, institutional-facing use cases, aside from those cases, you have a system that is actually gets the best of all worlds. I hope I explained that well. I can definitely answer more questions about it in the question section. And also, James, if I missed anything, let me know.
I want to take Q&A. I see some cool names here. Justin Drake joined, Angela Liu, DeFi Frog, Sriram Kanan. Would love to field some questions, but we'll go with Seg as the first question. Let's see if he can join here. Seg, if you can hear us,
I can hear
please
you.
go ahead. Ask your question.
Yeah, it just takes a couple of seconds to connect, so for future attendees as well. I just had a general question for whoever wants to answer it about a more modular blockchain world. One was, I heard Arjun speak about the liquidity layer. Fragmented liquidity is probably going to be a pretty big issue in the future. And one solution that I can see potentially is to have an application-specific chain or roll-up, for example, on Celestia that specifically deals with liquidity that talks to all of the other roll-ups that are trying to do general purpose stuff. Do you see this as the solution to liquidity fragmentation? And also, do you see a world where you have more application-specific blockchains than general purpose blockchains? Because I guess you can design a virtual machine that's more efficient for some applications than others, and do you see them talking to each other more than you just have a single dumb general purpose computer trying to process everything, kind of like CPU versus GPU type thing? Anyone who wants to answer can answer. Thank you.
I don't see fragmentation going away anytime soon. There really aren't many good solutions to this. Adding new application-specific AMM chains or stable swaps between them really just embeds the fragmentation deeper in the ecosystem. And adding new domains to try to resolve it just provides more routes for fragmentation to creep in. Fragmentation is a function of having many domains and many bridges between them. And I don't think that we can prevent that from happening or, unspill the milk on this one.
Go ahead. I was going to say there is an interesting incentive though, which is that, so basically, like just to take a quick step back. So fragmentation exists because, you have, potentially 5 or 6 different bridges that are all connecting the same chain, producing their own flavored asset, and that nobody has really quite decided which asset is canonical. Nobody's been able to take the time to figure out which asset is canonical. The chains themselves are of course trying to be agnostic, if they can, or in some cases they don't, and they say no, this is the right bridge. But even then, these are open systems, so you do end up having people coming in deploying stuff anyway. and giving you the wrong assets. And that's a giant pain for users. I agree that like it's a problem and it's going to be a problem. I think there is something that's kind of interesting though, which is that like having a stable swap, the one piece of incentivization here, which is interesting, is that like having a stable swap necessarily means, or even having some sort of like swap chain necessarily means that you are going to have one bridge, which is the one that is canonical, ends up becoming over time becoming the embedded version. Because if you have a stable swap, every single version of an asset, except for the one that you're swapping into, is going to have slippage as a fundamental part of transferring. So the assumption is that if you're, again, obviously markets are messy and it's unclear if and when this would happen, but the assumption is that if we are heading towards a world where everybody starts trying to optimize on price, everybody starts trying to optimize on slippage and user experience, there is this really interesting thing, which is that you can go to like asset issuers and say, hey, why don't you just like explicitly tell everybody this is the officially supported asset? And if they use this version of the officially supported asset, they can transfer it between chains without any slippage at all. I think that's an interesting economic lever. We're not sure yet whether it's going to work, but it is interesting.
One of the fun side effects of stable swaps is that when you have a stable swap between like 3 or 4 different fragmented versions of the same asset, typically that stable swap is going to incentivize creation of more fragments, first of all, to go into meta pools, and it's going to incentivize the minting of each of those fragments at about the same rate. So your ideal stable swap pool with 3 fragments is going to be 33% of each one. So by introducing this additional mechanism to try to fix fragmentation, you're going to end up incentivizing, higher TVL for all of the fragments. And you're going to end up with a huge stable swap pool that exists just to resolve the fragmentation issue that you kind of created with the stable swap pool in the first place. So as long as stable swaps are still incentivizing liquidity at the rate they are, I think this is going to remain true. And as long as you can make money by launching a stable swap, I think we're going to see fragmentation get worse.
I'd like to quickly interject here for our next question. Justin Drake, please go ahead and ask.
Oh, hi there. I was listening to the Bankless episode today on Celestia with Nick, and I love the name Celestium, and I guess I have a couple questions about Celestiums. One is, would it be fair to say that the security of a Celestium is kind of at best a degraded version of Celestia, and the reason being that when you have a settlement layer, for example, Ethereum, that settlement layer can't do data availability sampling itself, and so basically you lose data availability sampling as a security layer for your Celestium. I guess my second question is that Nick mentioned that the Celestia validators can make attestations, then these attestations can go on the settlement layer, and there would be some form of slashing if there's some incorrect attestations. And I guess my question is, how does this slashing mechanism work?
Yeah, so first of all, it's definitely the case that Celestiums do not have the same data availability guarantees as rollups for the reason that you stated, which is that the Ethereum chain cannot do data availability sampling of third-party chains, including Celestia. And so if you want if you want Ethereum smart contract to check data availability on a third-party chain, you have to use a committee-based assumption where some committee signs the block to attest to its availability, kind of like a data availability committee. But the difference is that you can think of Celestia as like the data as a data availability committee with crypto economic assumptions, because in Celestia, the data availability committee is the kind of validator set of Celestia. And why this is better than a standard normal closed data availability committee, because you have this cryptoeconomic assumption where, because Celestia itself is kind of like a normal blockchain used by other applications, and the purpose of Celestia isn't solely to provide data availability for some specific Ethereum rollup. It's just a standard blockchain in its own right, and with a proof of stake, validator set and so on and so forth. And because Celestia has data availability sampling, and we have data availability sampling like clients, so that if a block producer produces an invalid or attests to a block that's not available, the light clients can detect that. The light clients in Celestia can detect that thanks to data availability sampling, and they can halt the chain and then slash the stake of the validators that signed that invalid block. So you can kind of think of it as you can kind of think of it as a more secure, a slightly more secure version of a Plasma or a Validium, in the sense that you have this cryptoeconomic security.
I would actually like to. Oh, go ahead.
No, I was just kind of summarizing in my own words, which is basically that you're using the data value sampling as a mechanism for the light clients to enforce the slashing of the committee of validators.
Exactly. That's the plan.
Yeah, I'd also like to add some nuance here, which is that most committee-based bridges, not just most, but all the committee-based bridges that have been deployed so far essentially don't have slashing, which is why analyzing this new thing where there's actually a way of penalizing the committee, in this case the Celestia validator set, through slashing if they do in fact misbehave, essentially, either making an invalid block or equivocating or something like that. There's kind of this subtle thing in the analysis, which is that if you model it where the cost to corrupt the bridge is simply the cost of 2/3 of the stake, because say 100% of the misbehaving validator stake will get burned, so at least 2/3 have to be malicious. So the cost is 2/3 of the stake, which could be in the billions of dollars or whatever, who knows. So this would already be an enormous cost, but if you say that's the cost of corrupting the bridge, that's true if there's no slashing. If there is slashing, things get a bit subtle, because you can say, what is the cost of corrupting, let's say, Ethereum today? What's the cost of corrupting Ethereum from the perspective of an Ethereum application? You could say that it's 51% of the hash power. Proof of work is a bit weird. If we consider proof of stake land, right? 2/3 of the ETH2 stake to corrupt the Ethereum chain, but that's not exactly true, because if 2/3 of the Ethereum validator set were to try to make an invalid block, everyone would simply reject it. So the cost of actually making something invalid is infinite. It doesn't actually matter how much is actually at stake in terms of dollar value. The actual cost of corrupting the chain is infinite, because it cannot be corrupted. So in that context, it's not exactly like, you can't analyze it in the same way that you can analyze classical committees, because there's this notion that you can slash the committee out of protocol. You can slash them in a way that you can't do it with regular committee-based bridges. So this isn't really presenting a conclusion or anything, but it's more that there's some nuance here, that it's not a simple analysis of, here's X amount of money you can corrupt the bridge, here's X amount of money you can corrupt the L1. There's some subtle differences here, because you should be modeling the cost of corrupting an L1 is essentially infinite. Okay, that's all I had to say.
Justin, I'll give you another opportunity if you want to say something before we move on to the others.
No, that's all good. Thank you so much for the answers.
Thanks. Sriram, we'll go with you next.
Hi. Thank you. Actually, I want to pick up on a thread started by Justin here, trying to understand the crypto economics of slashing when data is unavailable. It seems there are fundamental differences between what happens when you have something invalid, when a committee signs an invalid message, versus when the data is unavailable. When the data is unavailable and a two-third majority committee is actually signing a block in favor of this unavailable block, it seems it's quite difficult to actually enforce slashing, even if light nodes are observing this, because that committee could temporarily withhold data and then later reveal it. And I think the point that John Adler just made on the cost being infinite is the cost is infinite to fool one of those light clients. But really, as the Twitter space is really secure bridging in a modular world, you could still fool the other side of the bridge, because the other side of the bridge is Ethereum or something else, which simply cannot parse anything more than whether there is a two-third committee signature. So the broader question is, how do we enforce slashing for data availability? Because that's, while it's perceivable, there's also ways in which you can hide data, withhold data for some time, and then later reveal it, as well as how do you protect it across a bridge? Thank you.
Yeah, so with this attack that you mentioned, where you can withhold data temporarily, and then release it later. So in Celestia, there's this big subjectivity assumption, which is kind of embedded into the Tendermint protocol anyway. So because we use proof of stake, so there's this kind of there's this 3-week unbundling period in the Cosmos proof of stake protocol, and so we rely on this big subjectivity assumption, which basically says that if you kind of go offline for 3 weeks, then in order to kind of sync the chain from scratch, you have to ask a friend to let you know what's the true, the trusted or true hash of the network, the block height of the network is with the block hash. And so, which means that's the first thing. So, which means firstly, if a block producer withholds a block, and then that client sees it's not available, but then the chain somehow moves forward, and then it actually releases the historic block in 4 weeks, that block will still be ignored, even though it's available in the future, because of this weak subjectivity assumption. But secondly, the second thing. So, were you going to say something?
No, go on. I think I was going to say that the weak subjectivity period therefore bounds the period of withholding.
Yeah, that's the first thing. But the second thing is that because Tendermint is a fork-free protocol, which means that if the validator set misbehaves and forks the chain and creates 2 conflicting block headers, then that's considered to be kind of like a safety failure. And what happens is that all the nodes and clients in the network will simply halt the chain, and so they will stop processing new blocks and abort the node, and then you have to kind of go back to social consensus in order to kind of recover the chain, which means that if the block producer has withheld the latest block, you can't really kind of proceed to the next block until that block is released. So there isn't really any, because there's no concept of forking. There isn't really any concept of a historic block on a different fork of the chain that's longer has now become available, and now that's the real fork of the chain.
Sriram, any follow up to that?
Yep. It seems therefore that all I need to do to attack the chain is I get a 2/3 committee, sign a block, withhold the block, and then I have a 3-week period in which I can release that block. I don't produce any conflicting blocks. I just withhold that block. So the cost of actually executing this attack, rather than being infinite, is actually 0.
But that would violate the weak subjectivity assumption.
Only if I don't release the block within 3 weeks.
So okay, if you release the block within 3 weeks, but why would that violate the assumption? Isn't that like why does that violate the protocol as long as that's like the latest block? It just means all that means is that it takes 3 weeks to finalize that block, but the block is
So if I'm
still
running an
available.
optimistic rollup on Ethereum, nobody could contest that block if I keep the contesting period less than the week subjectivity period.
Oh, I see. Yeah, so in which case the week subjectivity period, well, challenge period will have to be longer than the week subjectivity period.
That's right. So it seems like fundamentally
Yeah.
the data availability finality is over this week subjectivity period, and all crypto economics is relative to that.
Yeah, I think maybe John has something to add as well.
I would have to think about your question a bit. It's a bit unclear exactly what your model is. So if you could ask us offline, that would be great.
Absolutely.
Sriram, thank you so much for your question. We will now move to Angelfish. Please ask your question.
Hello, everybody. I've been thinking a little bit about how a modular world would give rise to things such as cross-chain MEV, and thinking about how the most popular way that it could manifest would be in terms of multi-domain arbitrage. But this could serve as a centralizing force because people that could capitalize on this arbitrage opportunity would either have to have money on 2 chains or 3 chains where the arbitrage opportunity is and swap them at the same time, or the sequencers would be incentivized to collude to get these opportunities. So for Nomad and Connext, I'm curious whether you guys modularizing bridging could be an avenue to democratize cross-chain arbitrage opportunities specifically. And for Celestia, I'm curious how, in a more general sense, how you guys deal with ordering, and could data availability layers be a good hub for somebody like Flashbots to build on top of to enable multi-chain block building?
It's a really good question. So, wait, can you hear me?
Yes, we can.
Okay, cool. So there's on the interop side, there's a couple of really important points here. So there is arbitrage in general as a space, cross-chain arbitrage particularly, and there's some really interesting stuff there. But there's two things that I think are kind of like potentially problematic. The first is you talk about cross-chain MEV, which is like allowing front runners extracting value from a transaction that goes across chains. For example, say you do something like in a single transaction, swap on Uniswap on Ethereum, bridge those funds, and then swap on some other DEX on Evmos. And because this is happening in an asynchronous paradigm, it is possible for some front runner to see that the transaction happened on the sending chain, and then front run the transaction, see the event that happened on the sending chain, front run the transaction on the receiving chain. Unfortunately, there's not a lot of ways to get around that. One thing that we've explored is potentially the data that goes across chains to call the receiving chain contract, encrypt that, and then decrypt it. You would basically decrypt. You'd have some sort of it's messy. You'd have to encrypt the data that is being emitted in the event and then decrypt it on the receiving chain, and then have push that into the contract. You would still be subject to on-chain MEV, but you would not be subject to this cross-chain front running attack. But that one is super messy, and I think unfortunately it doesn't seem like there's a lot of ways to get around it. The other one that's even more messy is actually the paradigm that is currently being followed by things like Synapse. And this is actually where I think the bigger problem rises, which is a situation where you actually have an AMM itself that straddles multiple chains. And so you have a liquidity pool on one chain and then a liquidity pool on another chain, and then you are determining pricing between those two chains based on the size of those liquidity pools when a transfer occurs. And the fundamental problem there is that you're introducing asynchrony to this model that is not designed to be asynchronous. There's a kind of two approaches to building distributed systems. There's the approach of like having asynchrony in your distributed system, and then there's like what are called CRDTs, where you just have like reconciliation happen after the fact in a conflict-free way. And I'm kind of bearish on the whole concept of like, let's build an AMM that has like pools on different chains for exactly this reason, because as is currently happening with Synapse, it is extremely possible for people to just manipulate the price of the AMM itself directly as like liquidity goes across chains by simply sending transactions in the opposite direction and front running users. Yeah.
So one more future avenue that we're really interested in. Right now, MEV largely relies on these miners running specialized nodes that, the Flashbots nodes. Because cross-chain communication is asynchronous, building that kind of thing for it is much more difficult and more complex, but it's still possible. A lot of these Tendermint zones, for example, share big chunks of the validator set. And hypothetically, those validators can use their leeway in the Tendermint protocol to bring those chains into something resembling synchrony that only the validator can access. So because Tendermint is fork-free and because it has one block finality, they can, in effect, if they are validating both of those chains under certain circumstances, bring those chains into synchrony, make transactions on both chains in a synchronous manner, and have whatever effect they want to. So we're really interested in this in the future. It is a much more long-term research avenue. And again, it relies on running custom node software on dozens of validators across dozens of chains.
Mustafa, John, anything to add on Angelfish's question?
Nope, James gave a pretty good answer.
Okay, cool. Well, I think we can wrap up here. James, Arjun, you guys are our guests. We will leave you with closing thoughts. Arjun, why don't you go first? As it relates to the modular blockchain thesis and most of the stuff we talked about, what are your closing thoughts on this Twitter space, and what would you like to leave the audience with?
Oh man. Yeah, I mean, I think there's so many closing thoughts. So I think like modularity is a term that is probably going to be used more and more as we like explore this space. It does seem to be the direction that a lot of decentralized network development is going, because I think people are beginning to understand that it is better to have hyper specialization at each layer of the stack. And so yeah, I would love to see more people kind of getting involved in that research and getting involved in this conversation. It's fantastic that like we have Celestia here. It's fantastic that like the modular thesis is playing out really well in like a bunch of different ecosystems. So I think just getting more researchers involved is certainly going to make it much more, is going to help us get to solutions faster. Yeah,
Okay.
Also, thanks for having us.
James, you.
Yeah, definitely. So the great part of the modular blockchain thesis and modular bridges is we get to specialize, we get to isolate things in their own domains, and we get to work at the boundaries. The whole project of bridging and the whole project of cross-chain communication is to work at the boundaries between these different ecosystems, to reconcile their differences and build something coherent on top of them that interacts with them directly. That's what I really enjoy doing, and that's what like keeps me coming back to it for so many years. As this ability to work with so many systems, learn so many things about each execution environment and each chain, and then to bring them into practice and write code for them. So if that sounds fun to you, definitely reach out.
All right, everyone, we'll conclude at this. Thank you so much. One last piece, Celestia is hosting the Modular Summit at DevConnect in Amsterdam next month. And I believe Anatoly from Solana will be in attendance with a one-on-one with Mustafa. It will be exciting, and there will be more on Twitter for that. Thank you so much for your time, James, Arjun. We'll see you guys when we see you guys.
Thanks for having us.
Mustafa, John, thank you.
Thank you.
Thanks.
Thanks so much.